Alright, today we are talking about special angle pairs. We have 6 different angle pairs that we are focusing on today. Okay, those 6 different angle pairs are perpendicular lines, adjacent angles, vertical angles, complementary, supplementary, and linear pair. So, to get us started, perpendicular lines are line segments or rays that form right or 90-degree angles. So when we look at this picture, okay, we have 2 lines here. We have AC and we have DB, and they intersect to form that right angle, which we know because they put that box in. We could write that as line AC is perpendicular to line DB. That upside down T represents the word perpendicular. Okay, if those lines are perpendicular, then we know that technically all 4 angles equal 90 degrees. Now, I've only written down 2 here. Okay, but angle ARB, that angle would be 90, and then DRA would be 90, and all of these angles would equal 90 together. Okay, the next one that we're talking about is adjacent angles, and adjacent just means next to. Okay, so it's an angle that shares a common vertex and a common side. So if we put some letters on this picture, let's say A, B, C, and D, then both of these angles, here's angle 1 and angle 2, share the vertex B, and they share a common side. That common side would be BC. So we know that those angles are adjacent. Now, adjacent angles don't have a specific equation. We would only be able to say that angle 1 plus angle 2 would equal the whole angle, which in this case would be angle A, B, D. And that goes back to our idea of part plus part equals whole. Okay, complementary and supplementary are very similar to each other. Complementary is any 2 angles that have a sum or add to 90. Okay, now these complementary angles don't have to be adjacent. It can be any 2 angles that add to 90 degrees. So, in the picture that you have, we have angle 1 plus angle 2 equals 90. Or we could have named those angles angle ABD plus angle DBC equals 90. So your equation stem here is angle plus angle equals 90. Now your easy way to remember complementary is if we draw in this line right here, then this looks like a 90, so we would have 90 degrees. Supplementary is similar, okay, except now with supplementary we have angles that add to equal 180. Again, these angles don't have to be adjacent, so it's just any 2 angles that are 180 degrees. So we could say angle P and angle Q are supplementary. Okay, so angle P plus angle Q equals 180, or in this case, 120 plus 60 equals 180. Now, similarly to complementary, we could make this S, here's my S, into an 8, right here. Okay, the U could become a 0, so 180 is supplementary. So our equation stem is angle plus angle equals 180. Now, vertical angles and linear pair, you see, have the similar picture, but they have completely different meanings. Vertical angles are 2 non-adjacent, so they're not sharing a common side, formed by 2 intersecting lines, and they are angles that are across from each other or opposite. Okay, so when we look at this picture, we have angle 1. Okay, now angle 2 is adjacent because they share a common side. Angle 4 is adjacent, and they share a common side. So the vertical angle to angle 1 would be angle 3. Likewise, we have angle 4, that would be vertical to angle 2. Now, when we have vertical angles, we also have congruency. So these angles would be equal. So your equation stem here would be an angle equals an angle. So, if opposite angles are equal, then the adjacent angles are what we're talking about with linear pair. So a linear pair are adjacent angles that form a straight angle, and a straight angle is 180 degrees. So we have 4 different linear pairs on this picture. Remember, when we have a straight line, a straight angle, okay, that's 180. So angle 1 and angle 2 equal 180, and angle 3 and angle 4 would add to equal 180. Then we would also have this other line, so 2 and 3 would equal 180, and 1 and 4 would equal 180. So our equations would be angle 1 plus angle 2 equals 180, angle 3 plus angle 4 equals 180, angle 2 plus angle 3 equals 180, and angle 4 plus angle 1 equals 180. The main difference between supplementary and linear pair is that a linear pair has to be adjacent. They have to be side by side. Supplementary just means any two angles that equal 180. So we're going to look at some examples where we have to solve for x. So if we look at example 1, it says MP and QR intersect at point O. Find the value of x. Now if you look at this picture, you see that we have this little box, which means we know that that angle is 90 degrees. So we would also know that line NP would be perpendicular to line QR. If that angle is 90, then we know all of these angles are 90. Okay, so we have perpendicular lines. So when we set up our equation here, we would have 5x minus 5 equals 90. And then y'all know how to solve the equations at this point. So I'm going to solve this one. Okay, and we would end up with x equals 19. Okay, so that one's pretty straightforward. Moving on to example 2. On example 2, it says AC and DE intersect at point B. Find the value of x and the measure of angle EBA. Okay, so we have to look at the pieces that they gave us. They gave us 2x plus 20, which is this angle, which would be angle EBA. And they gave us this angle, 3x plus 15, which would be this angle, angle DBC. And we have to figure out which one of our angle pairs that is. So if they are not adjacent, they're not touching each other, they just share a vertex, then they are vertical angles. With vertical angles, we know that they are congruent or equal, so we could say 2x plus 20 equals 3x plus 15. Remember, we have to be careful when we're solving these types of equations because we have numbers and letters on both sides. So I subtracted the 2x. You could have gone the other direction. Okay, these canceled, the 2 canceled there, so we end up with x equals 5. But we're not quite done. We've got to go back and plug that into angle EBA. So angle EBA was 2x plus 20, so we're going to say 2 times 5 plus 20, which ends up being 30 degrees. Okay? So, continuing on with this idea, I'm going to skip to example 4 here, because I think it makes more sense to look at example 4 before we do example 3. Okay, it says line LN and line OP intersect at M. Find the value of x and the measures of angle LMO and OMN. So again, we're looking at our picture. We have this angle, LMO, which is 7x plus 20. Okay, and then we have OMN, this angle, which is 5x plus 10. And if you look at those angles share a common side, which means they're adjacent, but they also form that straight line, angle LMN, that straight angle, which means they are a linear pair. So we know that our linear pairs add to equal 180. So we would say 7x plus 20 plus 5x plus 10 equals 180. Remember, we got to combine like terms. And then you're just solving. Okay? So if we get 150 divided by 12, then we end up with x equals 12.5. And then it wants the measures of those angles, so we're going to just plug that back in. And we're going to have 7 times 12.5 plus 20, which is going to end up giving us 107.5 degrees. And then we would have 5 times 12.5 plus 10, which would equal 72.5 degrees. So those would be all of your answers. So it's really just about finding the equation stem and then plugging it in. So now we're going to go back to example 3. This one combines example 2 and example 4. So we know that those lines intersect and they want us to find the value of x, okay, and the measure of angle JIH. Now JIH is that angle right there, which we don't know anything about. So I'm going to call it y in a minute so we know what we're solving for. Now we have to look at what they gave us with our x's. Okay, so we know that this angle is 16x minus 20, and we know this angle is 13x plus 7, and those angles are non-adjacent, which means they are vertical angles. So to find x, we have to say 16x minus 20 equals 13x plus 7 because they're vertical angles. Now again, we're solving to get what x is. 3x minus 20 equals 7. Add 20, and we get 3x equals 27. So x equals 9. Now, with that, we have x, but we don't have y. So we need to take that x and plug it into one of the angles we do know to find the measure of that angle. So we're going to say that angle GIJ, okay, is 16 times 9 minus 20, which ends up giving you 124 degrees. So we know that this angle is 124 degrees, and this angle is 124 degrees. So to find y, we know that these two angles form a linear pair, which means they equal 180 together. So we started with vertical angles, but now we have to use our linear pair to find what y is. So to find y, we would just say 180 minus 124, okay, which would end up giving us 56 degrees. Okay, so the measure of angle JIH would equal 56 degrees. And then you're done. So, continuing on, we've got a couple more examples. Flipping to the back side of that paper, we are looking at example number 5, and it says if angle 1 and angle 2 are supplements. Okay, if they're supplements, that means we're dealing with supplementary angles. And we know that supplementary is equal to 180 because our s can turn into an 8. So we know that angle 1 plus angle 2 equals 180. We know that angle 1 is 2x plus 20, angle 2 is 3x plus 15. So we would just say 2x plus 20 plus 3x plus 15 equals 180. We're going to combine like terms, so 5x plus 35 equals 180. Subtract 35, and we get 5x equals 145. Divide by 5, and we end up with x equals 29. Now they didn't ask us to find the measure of either of the angles, so they just wanted x, so that's all there is on that one. The next one we have, example 7, we're going to come back to example 6. It says that the measure of angle 1 is 6x minus 3. And the measure of angle 2 is 7x minus 11. And they want us to find the value of x. Now this one, we have to look at the picture And we see in our picture that they give us the box, which means that those two angles together are 90, which means that we are complementary angles, using complementary angles here. Okay, now, yes, I know you're thinking, well, aren't those perpendicular lines? Well, AC and CD would be perpendicular lines, but the combination of two angles together makes complementary angles. So we're going to say 7x minus 11 plus 6x minus 3 equals 90. We're going to combine like terms. 13x minus 14 equals 90. And add 14 to both sides. We end up here with 13x equals 104. Okay, then we're going to divide by 13. And we end up with x equals 8. Now again, they didn't ask for the value of either of the angles, so we are just going to leave it at x equals 8. Now, our very last one, there are multiple ways to do this problem. I'm just going to show you one way. It says to find all of the missing angles. So if we look at our picture, okay, we know that a straight line forms 180 degrees. Okay, so these three angles are going to equal 180 degrees. So we're going to find angle 1 first. To find angle 1, this angle right here, we would have to add 110 plus 45 to get 155. And then we would say 180 minus 155, which gives us 25 degrees. So angle 1 equals 25 degrees. Those angles would be called supplementary because it's three angles that add to 180. Now, we could do that all the way around, but I want to show you that we have a different type of angle pair here also. Here's angle 2. Okay, and if we extend those lines that make up angle 2 here, okay, then we see that we have a vertical angle across from angle 2 that measures 110 degrees. So angle 2 would have to equal 110 degrees because of vertical angles. Now, I think you kind of get the gist of this, so we could also say angle 3 is vertical, and angle 3 would be vertical with 45 degrees. So angle 3 is going to be 45 degrees because of vertical angles. So likewise, we have angle 1, and angle 1 is vertical with angle 4, so angle 4 is 25 degrees. Now again, there's more than one way we could have done those problems, but I think that's the best way to do it. Okay, but if you can figure out another way, then I say go for it. So those are your 6 different special angle pairs. Okay, remember adjacent angles is on your angle addition notes. Okay, we didn't look at adjacent angles on here. But I hope that this helps you understand your special angle pairs. Bye.